All right, so this is the tricky problem, and now we're at a tricky spot. How do we figure out, are we coming at this from the top, the bottom, the left, or the right? So, again, math. I mean, logic in math, but we're going to look at the numbers. We're going to play with this up, down, left, and right. So, we know you want to shift, and we need to figure out, is this shift going to be positive or negative? So let's just start and say, well, our shift is going to be zero. We're not going to shift anything, but let's figure out how we're supposed to shift, and then we get down to the end. We don't need these prints anymore. Oops, excuse me. Then we're going to shift it based off of what we decide. So we need to know, are we above it or below it, approaching from above or below it, right? So if we think of that grid inside of there, um, well, let's decide, are we to the left or to the right of it? So how do we do that? Well, I want to know, so as opposed to top and bottom, by the way, um, are we to the side, right? So how do I know if I'm to the side? Well, I know I'm to the side of it if I'm within the y space of it. So if my current location, which is the event.y root, right? Well, if that is between cat x and cat y and cat end x, right? So I'm sorry, y is what I meant. I don't mean I meant y on both of them. I typed x on both of them. I corrected one to x. So if I'm in between cat x and y, then I'm to the side of it one way or the other. And mind you, since I'm only looking at this as if I'm close, then I know I'm close into the buffer, and then but I'm not there yet. So I must be to the left or the right of it, right? So again, if I respond to this immediately when I hit the buffer, then I know I'm not hit there yet. Now, that means I now need to know once I'm on this side. So here so let me just print this out. Print I'm to the side. I'm sorry, I need to put quotes around that. So let's check this out real quick. So Sarah, so to the side. Now here I'm not to the side, and there I am to the side. It's actually tough to see. Let me run that one more time. So here, oh, it does show up. Well, heck, that's tough. Oh yeah, well it's going to show up to the side every time. Um, yeah, no, that doesn't work, right? Because I'm doing the same check as I was up above. Um, well, what if I say, okay, I'm going to be close, but I'm not going to move until I'm super close. So I have a big buffer there, 50, right? So what if I am inside of the space? So I'm to the side of it, right? So I'm inside the space. Um, but I want to really focus on not when I'm at the space, but when I'm kind of really close. So, I can. This is again the paradox of putting the buffer inside of here that we said before. It was helpful. It may or may not be super helpful later on because I want to know the absolute cat location versus the buffer location. So let's tweak this. It's okay, by the way, to take an approach and say that wasn't exactly what I wanted. So let me say, well, let me change this to be minus buffer and this to be buffer, right? And then I'm going to change this to be plus buffer and this to be plus buffer. And I'm going to take buffer out of these right here. So I know that these are the absolute positions of my cat. And I know at this point I'm close to the cat, but I'm close within the buffer. So here, I want you to notice something. Now I can notice I'm close, but I can actually identify when I'm to the side and close because up here it doesn't change it. Let me just show you that again. When I go at this from the top or the bottom, it doesn't report me being to the side. But now if I get to the buffer, I can show that I'm close to the side, right? I can see that, okay, I'm approaching it from the side. All right, so that's much better, right? I need to fine tune my solution. Doing it the other way wasn't wrong to begin with, and I actually did it that way because I knew I need to be flexible in my code. I don't need to be stuck with one solution that that might be a better way to approach it. So now if I can detect them to the side, well, you know what? Here, this is good. So I'm close, and this tells me I'm to the side. But I don't know if you notice, I got awfully close. So let's just say if I'm to the what would I say? Cat minus buffer divided by 2. Let's say I'm kind of close to the buffer, but not quite there yet, right? Plus, oops, plus buffer divided by 2. So that way, now I'm to the side, and I'm getting kind of close there, but I'm not all the way on top of it. So again, I can play with that by using the large buffer amount. I can have the big buffer and the small buffer. I can have the cat wake up when I get close, but I can move it when I get closer. So what do I want to do when I'm to the side? Well, now it's actually kind of much easier to say, well, if, right, if the current location is to the left, well, that means my current x, right, event.xroot is going to be less than cat x. I think this might work, right? Then I'm going to shift. So if it's to the left, I'm going to shift x is equal to 1. Otherwise, shift x is equal to minus 1. So let's just see if I can do that. Let's see if I can get it to move back and forth that way. So if I come from over here, oh, look, it's moving. Cool. Let's do it the other way. Come over here, it's moving. Awesome. So let's move fast. Oh, wait, look. I can actually move so fast, my mouse so fast, that I shift faster than what this is possible. So what if I actually say, if I get inside the buffer, let's actually shift this to be buffer over 2. And this will be minus buffer over 2. So let's make it a little bit, so if I go fast, I can't catch up right away, right? If I go fast, I can't catch up right away. I can never actually touch it. Cool. So we got our cat running away. All right, well, if we're not to the side and we're close, then we must, therefore, be up and down, right? That seems to make sense. I'm close, but if I'm not to the sides of it, I must be up and down. And by the way, if I'm in the buffer, but I'm not the close buffer, then maybe I don't worry about it. Maybe I don't worry about shifting it. So what if I just copy and paste this? Let's try this. Event y, oops, y root is cat y. So if it's less than cat y, then I want to shift y up. Or if it's greater than y, I want to shift y down. Right? Let's try this real quick. Oh, look at that. Our cat's running up. And our cat's running down. Okay, so it's not perfect, but we're moving around, and that's good. Like we've got it running around a little bit. We've got our cat moving. So let's play with it some more. Okay, well, again, it's a little tough to do the total test. So if you come at an angle, you can see it only moves X or Y in our current situation. So it's not entirely perfect, but we can improve our logic. At least we have it shifting up. We have it shifting down. We have it running around a little bit. The nice thing here is now that we have a idea of how to shift it around, we can get to the last problem that we have, which is how do we keep the cat on the screen instead of just running away and running off the screen, right? The game ends really quickly, and then 5 seconds over later, it's broken if we do it like this. So think about that. See if you can come up with some idea, and we'll talk about that next. But make sure you get this part working first.